Hi, I am doing the Lab 2 Sweet Density. I have my Milky Way bar and I have my Snickers bar, which I just opened. The Milky Way has 52.2 grams, which is the mass, and the Snickers bar has a mass of 52.7 grams. So I believe density equals mass divided by volume. There's more mass in the Snickers. It's not by much, so 52.7 versus 52.2, but I think that the density for the Snickers bar will be more. So that is my hypothesis for this. I also have my ruler, which measures in centimeters. I don't know if you can see that, but it's got centimeters on it. And then I got my balance, my electronic balance. So first off, I'm going to check the Milky Way bar and take it out of here. Check the length, width, and height. So the length of the Milky Way is 8.75. The width is also, well, it's 2.75. And the height this way. Oh. Volume equals length times width times height. So 8.75 times 8.75 times 2.75 equals equals 66.17, and the mass of this, so this is 52.2 grams, the measured mass, or I mean not the measured mass, so 52.2, and then measuring it on the electronic balance says it is 1.8 ounces. 1.8 ounces. So 1 ounce equals 28.350 grams. So this is 1.8 ounce. So it's about 2 ounces. 2 ounces would be 28.350 equals 56.7. So if this was 2 ounces, it would be 56.7. So I'm going to say that it is about 55, the measured mass. Density equals mass over volume, so density equals 55 over 66.17 The density of this, the .831 is actually 0.8311923833, but I'm going to round it off to 0.831 because of the sig figures. That is the density for the Milky Way bar. The Snickers bar has a length of 9.25. And then 2.75 width. Then the height. Is 9.75. And volume equals length times width times height. So the length being 9.25 times the width is 2.75. Times the height, 9.75, equals volume equals 248.02. The mass of this says it is 52.7 grams. And measuring this on the electronic balance gives us 1.2 ounces. I figured that would be higher. 1.2 ounces. Because the other one was 1.8 ounces. That's weird. 1.2 ounces. So 1 ounce equals 28.350 grams. $28.350 times 1.2. So the measured mass will be 34.02. I did 1.2 ounces times 28.350, which is how many grams are in an ounce. So that gave me 34.02 for the measured mass. Density equals mass over volume. So the density equals 34.02 over the volume, which is 248.02. So 34.02 divided by 248.02 equals 0.1372, or 0.138. I rounded it off to 0.138 to have the right sig figs. I don't know if that's necessary or not. I just went ahead and did that since it has to be round off anyways because it's a very long number. 0.13716633576 is what I got in my calculator. So that would be the density. Now I'm going to cut the Milky Way. in half. So half of 8.75 divided by 2 equals 4.3. So I have to cut it down to 4.3. So hopefully this cuts right. I tried to cut one of these earlier and it did not cut in the middle. Right. Okay. That's about right. Perfect. So this first half, I'm gonna measure the length, which is 4. Like 4.2. The width, .6. 2.6. And the height is 1.2. So volume equals length times width times height, which would be 4.2 times 2.6 times 1.2 equals 13.104 is the volume of the first half of the Milky Way. The measured mass of this this gives us 0.8 ounces. And 1 ounce equals 28.350. So 0.8 times 28.350 equals, the measured mass equals 22.68. The density equals mass over volume, and the mass is 22.68 over volume, which is 13.104. So 22.68 divided by 13.104 equals 1.73 or 1.7. Rounded off to the right fix. So that is how much it is for the first Milky Way bar. Second Milky Way bar, the length equals 4.5. The width equals 2.8. And the height volume equal length times width times height would be 4.5 times 2.8 times 1.5. 18.9 is the volume of the second piece of the Milky Way, and the ounces being measured seems to have turned off. There it goes. 0.9. So 0.9 ounces times 28.350 equals 25.515 is the measured mass. Density equals mass over volume, and the mass being 25.515 over the volume is 18.9. So 25.515 divided by 18.9 gives us 1.35 for the density of this. This density is 1.35, and the other density is 1.73 or 1.7 versus 1.4. I think the reason why the density for the second one is a little bit smaller maybe is because I didn't cut it at the very middle. It's just very, very hard to cut these in the very middle. I'm not really sure what kind of knife you would have to have for that, but that's kind of interesting. For the Snickers, I will cut this in 2 pieces. If the length of this is 9.25, 9.25 divided by 2 equals 4.6. So I cut it at 4.6. My first piece has a length of 4.6. The width of it is 2.5. And the heights (1.3). So 4.6 times 2.5 times 1.3 equals 14.95 for the volume. This measured in ounces is 0.9 ounces. So 0.9 times 28.350 equals, the mass would equal 25.515, which is the same mass as the Milky Way. 25.515. And the density equals mass over volume, which is 25.515 over volume of 14.95. 25.515 divided by 14.95 equals, density equals 1.71 for the Snickers first piece. And the second piece has a length of 4.5. And the width is 2.6. And the height is 1.5. So volume equals length times width times height, which would be 4.5 times 2.6 times 1.5. So the volume of the Snickers half, number 3, or number 4, piece number 4, would be 17.55 for the volume. And the ounces to this would be 0.9 also. And 0.9 ounces times 28.350 would give us 25.515 for the measured mass. 25.515 divided by 17.55 would be the density, which is mass over volume. So 25.515 divided by 17.55 equals 1.45. So density, let's see. So the Milky Way bar has a complete density of 0.831, and the first piece was a density of 1.7, and the second piece was 1.4. And the Snickers had a density of 0.13, and the first piece had a density of 1.71, and the other Snickers piece had 1.45 as the density. So my hypotheses for Snickers having more of a density than the Milky Way is wrong according to my calculations, which I didn't think was going to happen because there was more mass in the Snickers. Which candy bar was most dense? The candy bar which was most dense, or had the most density, was the Milky Way bar. The Milky Way bar had more of a density on the second piece than on the first piece, but the second piece was more than one of the Snickers, but one of the Milky Way pieces was more than one of the Snickers. But my calculations will also be concluded and sent define density. Density equals mass over volume. It is basically how much space something is basically how I would define it. The density of liquid water is 1.0 grams over centimeters cubed. If you place the candy bars in a tub of water, what would the candy bars do? I believe the candy bars would sink in the water because the candy bars would probably have more density. These candy bars, actually they have less density than the water. So the candy bars would have less density than the water would, most likely. They would sink, and I guess just depending on how hot the water is, they might melt. That's about all I had to say.